Yesterday I talked about the first order recurrence relation. So what I'm going to do today is going a little bit further, talk about the long-term steady-state solution. And tomorrow we will be doing some practical problem. Just a quick aim for today. So by the end of the lesson, you should be able to recall what a first order linear recurrence relation is. You should know how to derive a recursive rule for first order linear recurrence. Display a first order linear recurrence graphically. I'll show you what to do, and then determine the long-term steady state solution. This is one of the typical questions that will come out for first order recurrence relation. You want to determine the long-term steady state solution. All right. Now, yesterday I've shown you this table. You can see that both arithmetic and geometric sequence, there's recurrence rule and explicit or general rule. Whereas for the first order linear recurrence, there is no general rule. All right. You just have to know the first order linear recurrence rule. That's it. There's no general rule. And for all three sequences, A is the first term. All right. So arithmetic, you've got the difference, the common difference. Geometric, you've got the common ratio. First order linear recurrence, you need to be able to determine the B and the C, the coefficient to term Tn plus C, so that you can find Tn plus 1. All right. Now I'm going to get you to try the first three questions. Can you try these three questions, please, from yesterday? All right. See if you could remember how to do it. You've got the question in front of you. So you need to use Tn plus 1 equals to B times Tn plus C. T1 equals to something. All right. So you will be able to do it by simultaneous equation, or if you like, use the first order difference, then find the ratio. It is up to you. I'll display that. I'll give you about 3 to 4 minutes to work on 3 questions. All right?
Wait, why are you doing it like that and not just like
this is just a recall from yesterday.
Then you have to get the equation still. Wait, so when you're doing this, what can you say? Can you just do the 5, 4 there, or can you
That's
have
right, for
to
those
say
two?
sub?
No, you don't have to just separate. Yeah.
Okay.
Yeah.
Okay.
Yeah, so we got the same thing, just by doing it a little bit different.
I don't know. I think this is quicker. Like an test. Have free, man. I need to do
This
that.
is where we go.
fun shit.
This is where we go our separate ways, Asher.
We disagree. Nah, it's pretty easy though, because you get rid of the C's anyway.
Now he thinks it's easy, hey. Now he thinks it's easy. No, don't forget. Don't forget.
The second one has to be count free. That's what it is. Oh, you're doing it by hand?
What'd you get for this?
If you take them, that goes.
3.4 plus 5.08.
1.6 there. Sounds about right. Then that's 1.4. He's fucking weird.
I got 1.4 divided by 4 equals J.
Did you get 4?
I got 1.4 divided 2b take negative 2b is 2b
No.
plus.
That's question 2.
No way, bro. Are you serious? That shit's... Bro. It's so annoying. Fucking serious right now. Piss off.
That's alright. How did you find it? Pretty easy. Pretty easy. What did you write? I don't know, you just have to write like a line and shit for the second one, right?
So how did you...
Yeah.
So how do you do this one, this method that you're doing here?
Just find the common difference first.
So it's...
Oh bro, that'd be
Yeah.
too easy.
So for this one, it's
Try
plus
then.
1, plus 2, plus 4,
And then find like the multiplier between
times 2,
two.
times 2.
That's your B. And then sub in like 5, 4. And then you get the 6. And then that's B.
Ease.
Bro, you may as well solve shit. You may as well solve this sum. Yeah, I think you're on the bullshit.
Don't tell me the answer though, we'll compare at the end.
You have to redo it.
I don't know, I think I'll pass the apps test.
Pass.
Yeah.
You should do better.
What do you mean? You gotta always aim for the pass.
This is what you did last year.
Yeah, and I got 80%, so you can't actually talk to me. Did you get 80%, Asher?
Yeah.
You sure, buddy? You sure you didn't get slightly less than 80%?
No.
Well, I think you did. I think you're lying.
I've got the stats there, man. Yeah, but shit happens when I get scared off this year. It's like, yeah, these kids coming in. Shit. But if you're doing shit, then you do shit. You won't get scared off.
Wait, do you think we actually will get scaled up?
I think the scaling will be a bit better this year because more methods students are doing apps. So if you do better, you will do
Give
better.
you a couple more minutes and then I'll show you
Did you
my
get B
solution.
equals 1.2, C equals -1?
Yeah, man.
Good man, you got it right then. Should be happy about that.
Did you do that by hand or? You didn't do that by hand. Bro, I was like, if you did that by hand.
The next math prodigy. You better start looking up to me, Asher.
I already do.
Oh, good man, good man, good man. They don't call me
Yeah, what do they call you?
the I am the math. I'm a calculator. They call me the living calculator.
Human calculator.
Take one. See, I did it quick. It's alright.
What did you get for the second one?
I have no idea.
No.
Oh wait, no, I have. I got B equals 1.2, C equals -1.
No, that's the third one.
The third one, okay, you gotta say that.
Alright, next one. B equals
7
negative
B
3.
-1.
C equals
C. See, if we kept it at this level, then it'd be fine. But it's always,
test?
yeah, they always
Nah,
like
they'll-
chuck in worded ones, and that fucks me over.
Nah, but some of the questions are really fucking easy. If you like
Yeah,
go,
some.
if you go to like last few years ago, like the first question you like continued the sequence, and it just goes up by like 2 or some shit, and there's just 2 marks for this thing.
Right, really?
Yeah.
So you don't even need any of this. You just need to see the difference and just.
I just gotta
I don't think that would be a problem for the human calculator.
we have fucking notes for calculation, so
I don't need them.
I need either.
I don't need them. I won't even bring a calculator to the test. That's how we go. I gotta make it hard, otherwise it would be too easy. B equals -0.3, C equals 5. Did you get that?
So good. Yeah.
Did you get it right?
Yeah.
You just gotta copy mine, and if you get the same thing, you know it's right. That's right. sequence generated by the recurrence relation determine the moment time.
All right, that's my answer. I've shown you two things, which is how I did the first one. I can do it either by using the common difference and then find the ratio, which means I can find B, substitute and find C equals to 3, or I use simultaneous equation. This one I went straight to do using simultaneous equation. I use classPad to solve it. Same with this, I use classPad to solve it. All right. So check that my answer is correct, but both methods can be used. It's up to you which one you want to use. Hopefully that reminds you what you could do in terms of finding the rules. All right. Now, what I want to show you next is actually the graph. Can you grab your classPad out, please? If you haven't got a classPad, get a classPad.
Yes, my guy. Yes.
All right, get a classPad from me.
That's,
So I want to show you how to do
these
this.
all match what we've got, and
No,
the middle
the
one
second
is.
one's
So I want us to have a
Yeah,
look
you
at the
must
first one.
Bro, he can't make a decision.
Tn plus 1 equals to 2Tn minus 3. D1 equals to 4. All right, grab your classPad.
Yes, sir.
Oh, yeah.
So just the first one, you've got to just trust me for the others, all right?
I trust you, man.
So the first one,
It's honestly bad watching shows. It's
all right.
Fuck up.
So you go to sequences and go to edit, clear all. So remember, you only have recursive for the first order linear. All right? So let's type in here. That is 2Tn. 2. Oops. I1 type is A1. 2. An minus 3. And then A1 is 4. All right? Tap on there. I don't want to show the, yep. I don't want to show the sum. So if I do that, you can see that the sequence is generated. Now, how do you plot that? In order to plot that, you tap on this little button here. On your classPad, tap on that. All right? Now, for me, because I've already, I've got too many things in there, so I've got to redo it. I've got to clear it. I just want.
Minus 3.
You can see that it's going all the way up. All right.
Zoom.
So here,
Expo.
this is what happened. It is going up and up and up and up. All right. It's going like it should be. Really, when you draw it in a good, in a proper scale, it will go all the way up there. All right. So it's really hard to see the information here, but if I restrict it to max of, let's say, 10. All right. All right, you can see, oh, hang on, the scale is not as good for Y.
Scout shit, my boy.
Y max should be just, let's say, still not right.
Some shit.
Where the fuck's my graph?
Have to zoom out.
I'm pretty zoomed out. It should be there. It was there a second ago.
Yeah, mine was there as well. It's gone.
Something's wrong with my skill. So let's try again.
I'll just try again, yeah.
Oh, we got it. There we go.
It'll finally load.
Yeah, you have to.
All right, when you plot
hit the
it,
graph again.
you can see that it's an exponential function, right?
Did you get the same thing?
So it
Yeah,
goes all the way
it's
up.
simple.
Now, when you really plot,
I changed
when you
it.
plot it in the exam or test, please do not connect the line. You must only show the discrete value. All right.
Yes. Again.
So, looking at this, you can see that in this case, when n is increasing, Tn is increasing as well. All right? So therefore, this one, you can describe it as long-term increasing solution. It's going approaching Tn as n approaches infinity, Tn approaches infinity as well. So therefore, this is considered as a long-term increasing solution. Whereas when n is increasing, the next one, Tn decreases. So you can see that it's going all the way, approaching negative infinity. Approaching negative infinity. All right? So therefore, it's called long-term decreasing solution. This one is approaching positive infinity. In this situation here, you're going up and down. All right? You can see that it's towards the end, it's sort of fluctuating around one number. That number here is called your long-term steady state solution. So this is one of the things that you really must know for your first order linear recurrence rule. All right? Long-term increasing solution, long-term decreasing solution, and generally there will be question asking you to determine the long-term steady state solution. Now what I want to do is, let's explore that. What is the condition for long-term steady state solution? So, in order to have a long-term steady state solution, the range of coefficient of Tn must be between -1 and 1 only. And it cannot be 0. Alright? It has to be between -1 and 1. If it is over -1, it is the long-term decreasing. If it is greater than 1, it is long-term increasing. Alright? So here, as n increases, Tn actually approach a particular value. Now, let's consider this. Can you actually generate the first maybe 20 terms of that using your class pad, please? Using your class pad, generate the first 20 terms. I've already got it done, so but I am hiding it at the moment. Got it?
No.
You need to get up the first 20 terms because I want you to look at observe from T9 onwards.
Okay.
Alright?
Oh, T9 is purchase 2. Right? Purchase 2. There you go.
Got it?
Yep.
Generated it? So it should look something like this. Correct? Now, can you say that T9 is approximately the same as T10?
Yep.
Approximately the same as T11? Approximately the same as T13? Now the same as T14, and so on and so forth. Do you agree? Yeah? So we can say that all this number is like 2.
No.
Correct?
Yeah.
Yeah? Do you agree? So therefore, we say that for steady state solution, Tn equals to Tn plus 1. That is important to know. Yeah? So if you know that Tn equals to Tn plus 1, we could substitute into this to find the long-term steady state solution. How do we do it? We substitute Tn and Tn. So you can see that this term, we are looking at Tn equals to minus 0.5 Tn plus 3. Got it? Happy with that? So when you're looking for steady state, always substitute Tn plus 1 as Tn. Or you can substitute Tn as Tn plus 1 as well. So it really doesn't matter. Or think about this, if this is B, and this is C, rearranging it will give you this. Tn equals to C over 1 minus B. It is up to you which one you want to use. I generally prefer to substitute Tn equals to B times Tn plus C. I like the substitution method. Alright? So that I don't actually have to remember this at all. This is just a rearranging of that formula, that's all. Let's have a look. with this, what happened is you can actually really draw a straight line towards the end. It's really hard to tell the difference between 1.9999 and 2.0001, right? So therefore, this is the steady state solution. So what happened is, let's solve this mathematically. If we think about Tn equals to Tn plus 1, substituting Tn as Tn plus 1, you know that there's an unknown. So you can think of those as x, solving for x, and therefore 1.5 Tn equals 3, and therefore Tn equals to 2. All right, so the long-term steady state solution is 2. Tn plus 1 will be the same as Tn. So it's always 2. Or if I use C, which is this one, and B, which is this, all right, you can use the same thing. And you'll find that, again, 3 divided by 1.5 is 2. Like I say, personally, I prefer to use this so that I don't actually have to remember or rearrange that. I'll just substitute Tn plus 1 equals to Tn. Now, so in this case, the long-term steady state solution is 2. All right? Or we can say that the sequence approaches 2 in the long run. That's just a technical term for you to use. All right, let's have a look at this. For the sequence generated by the recurrence relation, determine the long-term limits or long-term solution of these terms. So they might use the word limit, they might use the word long-term solution. All right, think of it. You may have the word limit, you may have the long-term solution. So I'm trying to use words that they would use in the exam. So how would you do this? You know that in the long term, Tn equals to Tn plus 1. Correct? So substitute Tn equals to 0.5 Tn plus 3. So therefore, 1.5 Tn equals to 3. Tn equals to 2. All right? Now, in the exam or test state, the long term, steady state solution is 2. All right? Same example, this is how you should set it up. This is how you do your working in the exam. All right? In the long term, Tn equals to Tn plus 1. Substitute in and then solve. Yep?
Sorry, how did you get 1.5
If you...
Oh shit, it should be 0.5.
0.5, sorry, it's 0.5 Tn, my fault. It's 0.5 Tn is 6. It's 0.5, thank you, Joe. You picked up my mistake. So when you solve it, state the long term, state the equation, substitute the equation in and solve it properly. Yeah, I do that sort of mistake, but not you, alright? Don't do that. It's me, I will do that sort of mistake. I don't have the pressure for the exam, you see. Alright, let's try this. We now know the value, you now know the long-term steady state is 28. How do you solve it? So if you know the long-term steady state solution is 28, so Tn plus 1 equals to Tn equals to 28. Can you therefore substitute into that equation to find B? Can you do that, please? Don't make a mistake like me, alright? That's very typical of me. I do that in my exam all the time.
Is this right? 28 equals
Yeah.
And then would you just say T1 equals -2?
Well, 1 second, 28.
So, oh no, you just solve it, wouldn't you?
21 equals 28b. B equals 28 over 21. Both share a common factor. It's like 4 over 3, I think. Just admitted you were failing the exam. Just admitted you were failing the exam.
And I got a common factor of 7.
Yep.
It's alright, buddy. You were close. You were close.
No, it's 4 over 3, but yeah.
3 over 4. But we don't.
Who wants to give me an answer?
Don't know. Because you're not like
0.75. Yeah.
0.75, yeah. This would be, it could be potentially one of the calc-free, all right? You must be able to do something like this.
Yes, my lord.
So 3 over 4 or 0.75, it really doesn't matter.
Just imagine running
Now,
down the exam room.
In the exam itself, with your calculator, because you are able to use fraction in it, sometimes you need to give it use the exact value, use the fraction, rather than 0.75. 0.75 the exact, but if you've got a lot of numbers, use the fraction. All right? Now, I'm going to stop here. You should have some exercises to do from our club, and tomorrow we'll look at some practical problem. And then Friday, I will do some revision, some summary, and Monday again, you have time to do some work, just the revision work.
Wait, so would you say